This video number 3, and we're moving from the book to some typed up notes that we handed out right here. It explains pretty much everything that you learned on the previous 2 videos. Everybody knows that x over x equals 1, or 3 over 3 equals 1, 5 over 5 equals 1. Whenever you have the same thing that's on top and on the bottom, they cancel out, it equals 1. So we know that. We also know that x to the third over x to the fifth, you could technically cancel out 3 of the x's that are on top with 3 of the x's that are on the bottom, which only leaves you 2 x's left over on the bottom, nothing left up on top, so we put a 1 up on top. So the answer is 1 over x squared. Now, we understand this, right? We should understand it at least. But the key concept that we learned yesterday on the previous 2 videos was that we need multiplication between the terms in order to cancel, okay? You need multiplication in order for you to cancel out terms, all right? It even applies when you're simplifying fractions, like 4/10. We all know that 4/10 reduces down to 2/5, right? But the real reason why it reduces down is because we're able to cancel. Once again, the 4/10, the 4 could be rewritten as 2 times 2. The 10 could be rewritten as 2 times 5. Because there's multiplication, the 2's are able to cancel out, and you end up with your answer 2/5. Okay, so you're only able to cancel out the 2's because of multiplication, all right? So if you had 2 plus 2 over 2 plus 5, right here, you can't cancel out the 2's. You just can't do it. Why not? Because of the multiplication up here, the addition up here and the addition down there. We all know that 4/7 does not reduce down to to 2/5. So you cannot cancel out 2's because of the addition. So once again, you could only cancel out when you have multiplication, not when you have addition or subtraction. Even with variables, right? So if we look at x plus 3 over x, you cannot cancel out the x's. You can't do it. Let me erase that. You can't do it. Why not? Why can't I cancel out the x's right here? I just said it. Because it has addition. That's right. Okay, you need multiplication in order for you to cancel. Now this was explained very well in the previous 2 videos. If you didn't watch them, please watch them. Okay, so even here we're not able to cancel out the 2x's, right? So we have a 2x plus 2 up on top. You might be thinking, oh, I'm going to cancel out this 2x with that 2x. You can't do it. Why not? Because you're not multiplying, you're adding, right? Okay. However, if you take a look at the top, the numerator, that's 2x plus 2. You could factor out the GCF of what? What could you pull out? What could you pull out? It's right here. A 2. Bless you. Okay, so you could pull out a 2 from both terms, and you have a 2 on the outside. You'll have an x plus 1 on the inside. Now, we really do have 2 times x plus 1 over 2x, which is really 2 times x. So now we really do have multiplication of 2 up here, multiplication of 2 down here. So we are able to cancel out those 2's right there. Does that make sense? Okay, so we're now able to cancel out the 2's. So our final answer is x plus 1 over that x. X plus 1 over x. Why were we able to cancel out the 2's? Because we have multiplication. All right, so the main idea that was explained on the previous 2 videos was you need multiplication. And here's a key concept. It's kind of like what we did yesterday on the 2 videos. The key concept today is that you can only cancel when we have multiplication. And we're going to use factoring methods to attain multiplication. All right, so on number 1, you have 3x up on top, 3x on the bottom. Yeah, the first thought is probably cancel these out, but you can't do it. Why not? Because of the subtraction. Again, you need multiplication, right? So step 1 should be always to factor out anything possible. Factor out anything possible from the top, from the bottom. Try to factor first. So on this section, 8.1, always factor first. So if you look at the top, there's nothing to factor. On the bottom, is there something to factor? Yeah, what could you pull out? The 3. So if I pull out a 3 from the bottom, let me zoom in here. If I pull out a 3 from the bottom, what's going to be left? X minus 3, correct? Okay, so I already rewrote this denominator. I rewrote it to this. It's the same thing. So what I want to do, so I don't get confused, I want to put a couple of lines through here because Here's my new denominator, okay? So I really have 3x up on top, and I have this on the bottom. Now, I really have 3 times x equals 3 times a binomial. Now I do have multiplication, which means that now I could cancel what? The 3's, right? This 3 up here and that 3 down there is gone. So my new fraction is going to be x left over up on top, and on the bottom the x minus 3. Now you might be thinking, hey, I want to cancel out these x's. Could you cancel out these x's?
No.
Absolutely not. Why not? Because of the minus sign right there, right? You need multiplication. So of course, you're supposed to think, could I factor out anything else? No, you can't factor. That's as simple as it gets. That's your answer. Any questions? Okay. Yep, moving on to number 2. Number 2, again, could I cancel out this x up here with this x down here? Could I?
No.
Heck no, why not? Because there's subtraction, there's addition, right? You need multiplication in order for something to cancel, all right? So we're going to try to factor. Now, if you look at the top, is there anything in common with the x and the 4? Could I pull out a GCF?
No.
No. On the bottom, there's 3 terms. Could I pull out a GCF? No. But that's pulling out a GCF is only one method of factoring. It's the first method you're always supposed to try. But it is a quadratic trinomial, and the a value is 1. We love those guys because most of the time when the a value is 1, we're able to set this up and factor by simply thinking what times what is a c value that if I add together or combine together is a b value. So what's that going to be? What times what is negative 20 that if I combine together gives me the middle value negative 1? Negative 5 times positive 4. That's right. Negative 5, positive 4. It doesn't matter if you put the positive 4 first or second. It's fine. As long as you have the right numbers, negative 5 and positive 4. Everybody sees that, right? So I could put a couple of lines through this so I don't get confused anymore. So I truly have this up on top and this on the bottom. So it would be technically wrong for me to cancel out this x with this x and this 4 with this 4 because of the addition. But if I look at the binomial as a whole, if I say this whole binomial x plus 4 is on top and that whole binomial x plus 4 is on the bottom, and technically I'm multiplying this binomial with this binomial. So I do have multiplication now. And now I am able to cancel out the whole thing x plus 4 and the whole thing x plus 4. Does that make sense? So our final answer on number 2 is going to be what? Exactly, 1 over x minus 5. Dang, I've been forgetting something very important, ladies and gentlemen. What I've been forgetting on these previous 2 questions is when we simplify, some books, now I'm cool with this answer right here, but some books want you to state the value that'll make it undefined, the value that'll mess it up. In other words, some books will say, yeah, this is the answer right here, but then they're also going to say, but x cannot be what? It cannot be positive 3. So they keep, in this book, I think they add this detail onto every answer. Okay? If you end up with an answer that's a fraction, that has a variable on the bottom, you can't have a certain value that'll make the whole thing 0. So technically what you're supposed to do is take the denominator and in your head or on the side, set it equal to 0 and solve. And it'll tell you the value you don't want it to be. X cannot be 3. Right here it's pretty easy. You don't need to really think about it. It's just 3 take away 3 is 0. So the value of 3 would mess this whole thing up. The value of 3 would make it undefined. So once you state your answer, you also want to say, but x cannot be 3. Okay? So on this one over here, because I forgot, there's my answer. And we're going to say, but what? X can't be positive 5. So there's my answer. Here's my little detail in addition to the answer. What do you guys think? So again, the first 2 videos were all about factoring so we could get multiplication. Why? So we could cancel. Okay, again, factoring so we could get multiplication, so we could cancel. Now, on number 3 here, we actually have 2 different fractions, and they want us to multiply them with each other. So step one is to factor everything possible. Okay, so this is going to be your first step always. Okay, so go through every numerator, go through every denominator, and see if you could factor anything, right? Factor everything, right? Don't just factor one thing, factor everything possible. Because the fact is, even though you have an x squared up here and an x squared down there, you cannot cancel them. You cannot cancel them. Why not? Because there's addition and subtraction. But when you factor, you end up with multiplication, and then you're able to cancel, okay? So step one is always going to be factor everything possible. And then after you factor everything possible, you should end up with a bunch of multiplication, which means that then you'll be able to cancel anything that's alike on the top and the bottom. I should have said numerator and denominator. And it doesn't matter if you cancel out something that's up here with something that's down here, or something up here with something down here, as long as you're talking about top and bottom, okay? So let me move these steps to the side over here. So step one, factor everything possible. I'm going to rewrite both fractions with the multiplication sign between them. And I'm going to focus in on this top numerator. What could I pull out there? What's the GCF right there? Thank you. X. Now what's left on the inside if I pull out an x? X plus 3. Excellent. Okay, how about this bottom one right here? Could I pull out a GCF from all three terms? No, but it is a quadratic trinomial. Quadratic trinomial. The a value is 1, so I should be able to try this. And all I need to do is think, what times what is positive 2 that if I combine together gives me a negative 3? What do you guys think? Negative 2 and negative 1, right? Negative 2 times negative 1, that is positive 2. And if I do add the negative 2 and the negative 1 together, I will get the middle term, negative 3. So we factored the top, we factored the bottom left. Let's factor the top right. Again, it's a quadratic trinomial with the a value of 1. So let's set up the parenthesis situation. And the bottom one is also a quadratic trinomial with the a value 1. We might as well set that one up also. And now let's actually go back and factor. Let's think, what times what is negative 2 that if I combine together is negative 1? What would that be? Negative 2 times positive 1, huh? Negative 2 times positive 1, that'll give you a negative 2 if you multiply them. And negative 2 plus 1 gives you the negative 1 that's in the middle right here. How about this bottom one? What times what is 3 that if I combine together is 4? That'd be a positive 3 times a positive 1. Okay, we should be pros at factoring by now. So now that we've factored everything, sometimes you can't factor everything, but you're supposed to always try to factor everything. Now that we've factored everything, we really do have multiplication. Check it out. X times this, and then this times this, and this times this, and this times this, right? And there's even multiplication between the two fractions. So we have a bunch of multiplication everywhere. What does that mean? That we could move on to step 2, canceling things out, because you could only cancel when you have multiplication, and that's what we have here. So, what could I cancel? The x plus 1 over here. There's an x plus 1 up there and an x plus 1 down here. Absolutely, let's cancel that out. What else? The x minus 2 right here, and there's an x minus 2 down here. That could cancel out. What else? The x plus 3 and the x plus 3. What else? That's it. Yeah, that's it. Don't say the x's. You cannot cancel out this x with this x. Why not? Because of the subtraction. Remember, you need pure multiplication to be able to cancel things out. So, our final answer for this one is going to be x is what's left over up on top over x minus 1 left over on the bottom. That's our answer, our simplified rational expression. And if we wanted the value that we want to avoid, we want to say but what? X cannot be what? X cannot be 1. Ta-da! Now that's not the answer. This is the answer. This is just an extra little detail, right? So we've run out of time here. We're going to pick up number 4 on the next video.